Okay, lecture number 5, and again we continue on where we left at last time. So basically last week we have like 2 major parts. First we talked about functions in more detail, about parameters and arguments, about what happens when we call the function. This is actually something we're going to talk about a bit more today. And then we talked about return values or returning values from functions, then a little bit about type hints, and then the other section was about lists, about iteration with for statement, which we can use with any structures, not just lists. We saw examples on how to iterate through strings, for example, and then the range function, which we can use with the for statement, which doesn't necessarily need to do any or doesn't need to be connected to lists, although it is useful, for example, when we want to change the list somehow. Then we talk about the count and replace methods and f strings a little bit, and then that's where we will continue today. Before that, a little bit about the exercises. This is again directly from the materials page, but something which I've been discussing with some people recently are the limits, or are the how many, or the fact that some people, or I think most people, find some exercises quite difficult. So please notice that the minimum requirement is 25% in each part, and I of course hope that you try to complete as many exercises as possible, but the fact that the minimum limit is 25 means that if there's an exercise you find very difficult, then it's perfectly fine to continue with the other exercises, and then maybe in a week or 2 get back to previous ones. There are no strict deadlines except for the exam you're going to take, meaning that if there are difficult exercises, you can skip them at least for some time, and then try to complete them later. It's also very natural that you find some of them difficult, as I said before. Some of the exercises are more difficult than others, and also the difficulty is not an objective thing, meaning that some of you find some exercises difficult and the others may find other exercises difficult, and that's perfectly fine. Also, the difficulty level is not linear, meaning that the exercises are not in any specific order of difficulty. So it's not always the fact that the first exercises are easier and then the final ones are more difficult, but there can be difficult exercises there in between as well. So if you think that the exercises are difficult, don't worry, some of them are, and it doesn't matter if you don't complete all of them, but I hope that you try to complete all of them, or at least as many as possible. Yeah, so just something that I've been discussing with a lot of people recently. Okay, then let's move on to this week's topic. So something we discussed at least briefly last week was the fact that when we are creating lists, we can actually store any items into a list. So all the examples we did last week were basically lists containing integers, but we can store any items in the list. It can be strings like this list of names, or it can be a list of floating point numbers like measurements or temperatures, or whatever floating point items, and so on. So basically Python doesn't limit the type of the items in a list anyway. And what this means is that we can also find the editor somewhere. We can also create lists where the items are other lists. So we can do something like this, for example. And what this means is that I now have a list of 3 items, and each of the items in the list is a list as well. And the reason for creating these nested lists or lists as items is basically the fact that it's an excellent way to model a matrix. So basically how we usually do it is we define that each of the sublists, well, maybe not sublist, but each of the nested lists models one of the rows in the matrix. So basically, if you have a matrix like this with rows 1, 2, 3, 3, 2, 1, and 4, 5, 6, then we can create a list which consists of 3 lists, and each of these lists inside this outer list now represents one of the lines in this matrix, like this. So the usual way is to define it in a way that each of these sublists is a single line. It could be also all of these lines, all of these sublists could also be, or could also represent columns. But the usual way is to do it like this. So what it means, if we look at this example, for example, is that when we are trying to, well, let's start with very basic. So what is the length of my list in this case? How many items in list my list? 3, yeah, exactly. So there are 3 items, and again, the type of the item isn't meaningful in this case. Length of the list is the number of items in that list. The number of items in list my list is exactly 3. Now, if you want to access individual items in that list, we can do it by using 2 index numbers. So I can do something like this. So what will the program output? Yeah, it will output 1. And the reason it outputs 1 is that this first part here accesses this list in here. So if you remove the second index number in here, if it just executes the program here, we get the list, the first item in a list my list, which is this list containing 3 items, 1, 2, and 3. And if we then access the first item in that list, then it outputs 1, which is the first item in the first row in the matrix. Okay, how about this one? It's 8, so it's second item in the third row. So again, this first part means that we access the third item in the list my list, which is this list in here, and then the second index 1 means that we access the second item in this list, which is this number 8 in here. So perfect. So what this means is that we have like 2 coordinates, except the first one is like the y coordinate in a matrix, and the second one is the x coordinate. But how I want you to think, or how you need to think about it, is that you first have the index of the row we are accessing, and then you have the index of the item in that row you're accessing. Okay, this also means that if we want to iterate through a matrix, we can write a code something like for row in my list, and if we just, so what will this output? Don't type all the items, but just like the basic idea what happens here. This is 1, 2, 3. The 3 items here, and what are the 3 items? That's exactly, the 3 items are the rows in the matrix. So we basically get all the rows or all the lists and like this. And now if we want to access the individual items in a matrix, we can have another for loop, something like for item in row, and then we can output the items one at a time, meaning that we get all the items from all the rows one at a time. So let's say that we want to calculate the sum of all items in a matrix. We can do it something like this. So the sum of all items in that matrix is 45, it seems. So if we need to access all the items, all the individual items one at a time, but the easiest way for any matrix is to iterate through all the rows with one for loop, and then for all the items in each row with another nested for loop like this. And this works with any number of items. Let's just output the items, probably easier to understand. So if we do it like this, we're missing some pieces in here. So basically, it accesses all the items from any matrix. And because in Python, we're modeling the matrix with list of lists, it also means that it doesn't need to be a symmetric or a complete matrix. Something like this is perfectly fine as well. And it still accesses all the items from each row one at a time. Let's change it back to this one. Okay, again, similarly to, just give me a second for someone. Okay, let's continue. Sorry about that one. Like we talk about with lists or with other type lists, if we want to change the list, then we can't use this for loop like this, because this gives us an access to all the items, but means that we can change the item. So if we want to change it, we need to use the range, or we can use the range function, for example. So we can do something like for I in range, then we go until the length of my list, and then again we need another for loop, and then in this case we access the row number I from the matrix, so it works with any shaped matrix, and whether it's incomplete, it doesn't really matter. And then we can, for example, increase the value by 1. So if we do this, and then we output the list, then we can see that all the items in the list have increased by one point. So we started with list with items 1, 2, 3, 4, 5, 6, 7, 8, 9, and then now we have the items 2, 3, 4 from 2 to 10. So each of the items is increased by 1. So basically, the idea is similar to what we were doing with lists before, but now because we are dealing with lists inside lists, we typically need to use 2 index numbers, and if we are iterating through the matrix, we typically usually need 2 loops as well. So like 2 nested for loops do just fine. Okay, let's see if we have anything else about this. Talked about accessing the items, and then we talk about iterating and changing the item values. Again, these slides are directly from the material. So, okay, so let's discuss something else for a while, and then let's get back to matrices. So let's talk about references, and let's start with a simple example. Again, let's have like list of values 1, 2, 3, 4, 5, for example. So what will the program output? From the numbers from 1 to 5, basically, yeah. Exactly. So it outputs the list with items 1, 2, 3, 4, and 5. So nothing new here. What will the program output now? And again, this is supposed to be a sort of an easy question. Yeah, so it's like from 1 to 5, except that now we change the first item, the value of first item to 10, so it's 10, 2, 3, 4, 5. Okay. How about this one? What will the program output now? What will the program? Yeah, that's a really good guess. And I'm asking you to guess at this point. This is something we haven't talked about before, but so let's see what happens. And if we execute the program, we see that it actually outputs 10, 2, 3, 4, 5. So what happens here, or to get to the bottom of why this one happens? Why is the value? Why does it show the changed item 10, even though we're changing the value by using the variable values instead of values 2? Is the question here. And what's happening here, to get to the bottom of this, we need to start with the fact that in Python, all the variables are references, something called references. And what it means is that when we are creating a variable, we are not actually storing the value into variable, but instead we are storing a reference to a value into a variable. And for some types like numbers or strings, we can't really see the difference because we can't change them. Those are immutable. So a string, something we discussed last time, when we create a string, it's an immutable object, so we can't change the string. And the same applies for numbers. When we create a number, we can't change the number itself. What we can do is replace the number with another number. So replace the value with another object or a reference to another object. But lists are different because lists are mutable structures and lists can be changed. So as we talked about last time, and as you've been practicing for the whole week, we can change the values of items, or we can append new items at the end of the list, or we can delete items or whatever we want to with lists. And so what this means is that once we create a list variable, it's also a reference to the list. So if we write something like a equals 1, 2, 3, then a is a reference to a list containing values 1, 2, and 3. Let's make the same exact example. It might be easier to follow. 1, 2, 3, this. And now if we output list referenced by variable a, we get access to the original list containing values 1, 2, and 3. So this is what we've been doing since week 1. Now, because lists are mutable and it's different. Here's the correct example. So now if I type this another line stating that b equals a, now what happens is that Python doesn't create a copy of the list. There's still only one list, but now there are two references to the same list. So basically it looks like this over here. So we have variables a and b, and they both reference the list containing 3 items, 1, 2, and 3. So if we output a or we output b, we still get the same list containing those values 1, 2, and 3. But this is also visible if we change the list like this. So if we change the item the first item in a list, for example, to 10, and then we output the list by using either of the variables A or B, we still get the same values 10, 2, and 3. And this is because we only have one list, like this image tries to illustrate here. We have one list with 3 items, but we have more than one variable referencing that list. So how you should think about this, it's like having a house on the crossroads of two separate rows or something like that. So you may have a house which actually has 2 addresses, but it doesn't matter which of the addresses you're using, you're still talking about the same house. Only one house, but 2 addresses. So in this case, only one object, only one list, but with 2 references. And there can, of course, be any number of references to the same list. So it doesn't matter whether we're using variables A or B, we're still accessing or changing the same list. Why is this meaningful? Is that you're probably not going to do this. You're probably not going to write like many variables referencing the same list, but it's more meaningful, and something you are going to do is that you're going to write a function, something like a function which received a list as an argument. So let's do it like this, and then no space over there. Let's do something with the list. Let's change the first item. And now take notice that this function doesn't return anything. So it's basically a procedure function. So it doesn't return anything. It just changes the item of the first, or it changes the first value of the first item in a list referenced by variable mylist to 10. So let's create a list. Then call the function change list. Oh, it wasn't, sorry. The values, and then output the value of variable value. So what will the program output? Yeah, it will output 10, 2, 3, 10, 2, 3, 4, like this. And the reason for this is that although it's a different variable, what happens here is that when we call the function change list, we are actually providing the reference to this list as an argument, meaning that now these variables, this variable values and this variable mylist, they both reference the same list somewhere in memory. So when we change the item to 10 in here, and then we exit the function, and then when we output the list, we see that the value has changed because we're still talking about the same list somewhere in memory. So something like this is perfectly fine, but let's see something different. So what I'm trying to do here, or what I am doing here, hopefully, is that there's a function second smallest, which returns the second smallest item from a list. Let's have a list. Like this, and let's see what happens when I call the second smallest with the numbers. So let's execute the program, and okay, it returns 2, and 2 is the second smallest item in the list, so it seems to work. It doesn't probably necessarily work in all cases, because if there are, again, if there are duplicate values, then we need to define what do we mean by second smallest, but for this case, it seems to work fine. What's the problem with this one? I mean, it seems to be working okay. What is the problem? Or let me rephrase that. What might be the problem? Let me illustrate the problem with something like this. Yeah, that's one of the problems I actually sort of tried to mention before, that it finds a second value. If there were two ones, it would give one instead of two. But if we don't talk about that for this case, if that doesn't matter, because yeah, that's definitely, but that wasn't what I was looking for. But that's definitely correct. That is sort of the problem with that one. But let me illustrate what I was looking for. So let's have a list of names. And then let's have people's ages as well in another list. So let's say that James is 24, Jane is 61, John is 11, and Lisa is 19 or something. And then do something like this. So let's execute that and see what happens if James is 24 years old. And so this is how we're doing it in our program. We have a list of names and a list of ages. And so James is 24, Jane is 61, John is 11, Lisa is 19. And let's find out which the second largest age. Sorry, second smallest age is. Okay, so second smallest age is 19. That seems to be fine. What is the problem here? What just happened? Let's do this one again. So James is 24 years old. The second smallest age is 19. James is 11 years old. So what happened? Why did James become younger so fast? Oh, I don't think that the speed is actually the problem here, but the fact that James actually got younger. Yeah, the list got sorted. So what I'm trying to illustrate here is that this is problematic. We might be storing names and ages like this in our program. There might be other better ways to do it, which we will talk about later today, but still this is something we might be doing. And we just wanted to find out which is the second smallest age for some reason. And after this one, our names and ages are no more connected. And the reason is that we just, what we did here, we sorted the list of ages. And because these variable values and these variable ages reference the same list, the change is also visible in our main program here, meaning that James is now 11 years old instead of being 24. So what's happening here is something called a side effect of a function. I have a, hopefully have a, yeah. So it means that it's the same exact example. It seems the idea is that if a function does something like creates a change or changes the object somehow, and that isn't like the main purpose of the function, then that's called a side effect. And in this case, we want to get the second smallest item, but now it changes the order of the items in a list, and that definitely isn't the meaning of this function. The meaning of this function is to return the second smallest item, and but it also messes up the original order of the items in here, and this means that after calling this function, our program may not work as intended anymore. At least the names and ages are no more connected. So this is also an undocumented side effect, meaning that there's nothing in the function, well, there's no commenting, but there's nothing in the function comment stating that it changes the order of items in these values. So what can we do to fix this? Yeah, we can use the sorted function, for example. I think that's an easy fix for this one. So we can use sorted values and then pick the second item from that sorted list of values. And now when we execute the program, we can see that James is 24, the second smallest, age is 19, and James is still 24. So now it doesn't break the main program, and it just doesn't mess up with our order of items, which in this case is meaningful. So side effects are something you need to avoid. Basic idea is that when you're writing a function, it should perform the function or it should perform the operation it's meant for. So if it's the function called second smallest, it's supposed to return the second smallest item from the sequence or from the list, but it's not supposed to mess up with the order or mess up the order of the items in a list. That's definitely a side effect. There's something to apply whenever you're writing functions. So it's perfectly fine if I have a function like sort items or something, and then this one actually sorts the items. And it's fine in here. It's not really a side effect because this is like the meaning or the original intent of the function. It's supposed to sort the items because that's what the function is written for. But in this case, the function is written for returning the second smallest item. And for that, it shouldn't be necessary to change the items in the list. So it's a side effect, and it's something we should avoid in our programs whenever possible. Also, these kind of side effects are possible because the values of variables are references. So we can have several references to the same list. Let's get back to matrices and see something else. So let's create or try to create a matrix consisting of 3 rows and 4 items in each row. What's the potential problem with this one? What am I doing wrong here? What kind of problems may this program run into later? And it seems to be working fine. There are 3 rows and there are 4 items in each row, but what's the problem? And I'm asking difficult questions today. So if you think that these are difficult, then they definitely are. Yeah, exactly. They all reference the same object. So what we have here is a list containing 3 items, but all of those items are referencing the same row in here. And we can make it visible by like this. Let's change one value in the matrix. Let's change one value after we have created the matrix, of course. So let's do something like this. Let's try to change the first item, the first row into 10 or 1, for example. And let's output the matrix, and now we can see that the first item of each row is now 1. This is not what we wanted. We want, if you're creating a matrix, we probably want to have all the values independent of each other and all the rows independent of each other, meaning that if we change the value in one row, it shouldn't affect any of the other rows in the matrix. So how to fix this? let's get rid of this code for a second, and let's talk about something we discussed really briefly last week. So let's have a list again. And last week we talked about sublists. And what it means is that we can take the original list and exactly like we extracted a substring out of a string, we can extract a sublist out of a list. So we can say something that from 0 to 3. And if we now output values 2, we see that we have a new list containing only the first 3 items in the original list. And now these two are no longer connected. So if I change the value in the original list, it doesn't affect the sublist because sublist is a new copy of the original list. So it doesn't change. Changing values in the original list doesn't change any items in the sublist. So let's use this one and let's start from the first item and go until the length of the list. So let's create the sublist that contains all the items in the original list. So effectively what we're doing is that we create a copy of a list. So now we don't have 2 variables referencing the same object. What we do have is 2 objects and 2 variables referencing those 2 objects. So we have values variable which references one list and values 2 variable which references another list. And to make this even more simple, we can leave out the 0 in here because if we don't define the first parameter in the sublist operation, then that's assumed as 0, and we can also leave out the second part because if we leave it out, then Python assumes that we mean that until the end of the list. So effectively, we get a copy of a list by just providing the square brackets and then a colon in between them. So this basically creates a copy of any list. So let's use it. Let's do a lot of undoing and get back to our matrix like this. And now instead of using the row variable when creating the matrix or when we are creating the matrix, we can use this copy operator and create a matrix containing 3 copies of the original row as references. And now when we change a single item in a matrix, we can see that it only affects that one row. It doesn't change any items in the other rows. So this is basically, or this is probably what we want. If we are creating a matrix, we want the rows to be independent of other rows. So that when we are changing an item, it only changes one item, not one item per each row. But again, this is similar behavior, meaning that we can have several references to the same object. It's important to remember that. Yeah. So any questions about these lists or matrices or references? There are some other things we need to talk about today as well. Again, this might be something you need to practice a little bit to get to fully understand this. And it isn't, again, it's a little bit complicated thing. It's probably one of the most complicated things in this whole course, I would say. Okay, just let me know if you want to ask anything. Let's move on and let's talk about something else. So let's talk about some other data structures. So we've been talking about lists for now, and even matrix is a list. It's just a list containing other lists. But there are other data structures in Python as well. And typically, all the data structures are useful or are more useful than other structures in some occasions. So lists are great when we have a lot of information which we usually handle as one entity, meaning that when we have, for example, when we have a lot of values and we want to do something with all of those values, whether it's about changing all the values or finding a specific value or finding the largest item or finding the longest name or whatever. But in all of those occasions, lists are great. But there are other occasions where we are mostly interested in one specific item in the structure. And in those occasions, dictionaries are usually great. So the basic idea of a dictionary is that there are key value pairs. Each item consists of two parts, the key and the value. And to access an item in the dictionary, we need to know the key. Items in dictionary don't have indices. There are no index numbers in dictionary. Instead, the keys are used as indices. So the basic idea is that when we want to access an individual item, we need to know the key. And for that reason, dictionaries are useful, for example, when we have a registry for students, for example, and you know the student ID, and then you can use that ID to access the student object from the dictionary. And accessing an item based on the key is really fast when we know the key. So it's a lot simpler to find the item in a dictionary if you know the key than finding an item in a list. But the downside is that you need to know the key, and the downside also is that the items don't have an order in dictionary. So we don't have like a first item or last item or anything like that. We just have a bunch of items which are accessed by the keys. And let's see a couple of examples before we talk about more, because this is, again, it's quite abstract like this. So let's have something like persons dictionary. And now when we create a dictionary, instead of square brackets, we use this, come on, I had the same problem last week. What do we call this? Curly brackets, yeah, exactly. I think I have this information missing for some reason, but curly brackets instead of square brackets. And now we can create an empty dictionary like this. And if we have an empty dictionary, we can add new items by adding a new key. See something like, let's have an use person's name as a key and then person's age as a value. So let's say the Peter is 25. And then when we output this dictionary, we can see that there's one item where key is Peter and 25 is value, meaning that the length of this dictionary is now 1. There's exactly one item. We can add more items. Do that. And then when we output the dictionary, we can see that now there are 3 items. In the first item, key is Peter, value is 25. For the second one, key is Paula, value is 33. And for the third one, key is Bob, and the value is 97. And there are 3 items in the dictionary. Now, if we change or assign a value to an existing item, Peter is 88, then instead of adding new item, it just changes the value of existing item. And this implies the fact that all the keys in a dictionary need to be unique. So there can't be 2 keys with the same value Peter in the same dictionary. So if we reference it or assign a value into it again, it doesn't add a new item, but this one changes the value of existing item. We can also add some items when we are creating the dictionary. Like this, and then that means that when we are adding new items, now we have a dictionary with exactly 5 items, if I'm correct. So we have 2 initial items when we create the dictionary, and then we add 3 items like this, and then finally we change the value of one of the items. We can access the item similarly. So if we want to output the age of Bob, then we just use Bob as a key to access the value from the dictionary, and we get 97 in this case. So it's pretty much like we did with lists. You assign new values by and new items basically by assigning a value into a key, which creates a new key item, a key value pair as a new item, or you change the value of the existing item by using an existing key, and you can access a value by using key, but you need to know the key to access the item or access the value, sorry. If we try to access an item that's not in the dictionary, so if I try to access an item with key David, this will give us an error. It's a key error. So there's no other explanation, but it means that the key can't be found in the dictionary. Again, what we can do is use the in operator to find out if a key can be found in dictionary. So in this case, it doesn't just print or output anything because key David can't be found in the dictionary. We can also iterate through a dictionary one key at a time. So this gives us an access to all the keys in a dictionary. We basically get all the names in a dictionary in this case. If I also want to access all the ages, I can just use the keys, of course, like this. So this gives us all the ages, or I can do something like use the items method for dictionary, and then I can just access both the keys and values of all items in the dictionary. So I basically get all the names and all the ages like this. So dictionaries are great when we are mostly accessing items based on some kind of key, some kind of identifying key. Now the key can be any type Python object, but it needs to be immutable. So we can use strings and numbers as keys, but we can't use a list, for example, as a key. And the value can be of any Python object. So lists can be used as values in the dictionary, but not as keys. Let's create something else. Let's have something like squares, which is a new dictionary, and then let's populate it to some extent. Let's do something like for I in range from 1 to 100. Like this. So after this one, we have a bit larger dictionary which contains numbers as keys and then the squares of the numbers as values. And how we can use this kind of dictionary. While loop. If the number is -1, then we break out, and if it wasn't, then let's find out if number is in dictionary. And if it is, we can say that square of num is, and then we can get it from dictionary like this. So let's try it out for some values. Square of 5 is 25, square of 10 is 100, square of 99 is 9,801, and so on and so on. So this is sort of a dumb example in a sense that this is not really useful in a sense that calculating a square is quite fast. But if we're doing something which is sort of ineffective to calculate, something like prime numbers or something similar, then it might be a good idea to use a dictionary to store the values, and then we can use the dictionary to come up with the value instead of needing to calculate the value each time again and again. So if you're actually doing this a lot of times in a program, something like this might be useful. But anyway, it's an example, the sort of demonstrating that the keys in dictionary can be any immutable Python objects. So typically we're using something like numbers and strings, for example, and then the value in dictionary can be any Python object, including mutable objects like lists and so on. One final use for dictionary, which is also listed in material, or one other use, is to combine values that are somehow connected. So we could have a dictionary, single dictionary modeling a person, for example. So we can use something like this, for example. Let's create another one as well. A little bit different. And we can then store these kind of dictionaries in a list, for example. And now this is useful when we have a lot of these. It should be example. And now when we want to, for example, iterate through the names of all persons, we can do something like this. Now we know that we can use the key name for each person, and then we get just the names of all. Oh, it's for S in the. So names of all persons in that list containing dictionaries. So sometimes the dictionaries are used like this as well. There are also other ways to do this. We're going to talk about one in a minute and one in the advanced course. But this is one possibility if you have a data that's somehow connected. So for example, persons properties or something like that, which you want to connect into a single structure with, and then it's easy to access all the individual properties of each of those persons. Okay, the final thing for today, let's see, is another structure called a tuple. And the tuple, it's a list-like data structure, so using it is rather simple. It's the syntactical difference is that instead of square brackets or brackets, we use parentheses when we create a tuple. Something like this, for example. Because so this creates a tuple with two items. Tuples are also immutable, meaning that we can access items from tuples like this. This is perfectly fine. This returns value 10, the first item from this tuple, but we can't assign values in the tuples. So this will give us an error stating that that's one first, but then another one as well stating that the tuple object does not support item assignment. So we can't change the values, we can't append items, we can't delete items from a tuple. Tuple is an immutable object. So what is the reason of using tuples? Why not use lists? Because we have seen before that the fact that the lists are mutable is actually useful. We can add items and so on and so on. the reason we're using tuples is that they are meant for different things. They are meant for basically connecting values. Tuple is basically like a collection of values that are connected somehow. So if a list is a collection of similar items, like list of names or list of ages or list of temperatures or list of results or list of anything, tuple is basically a collection of connected values. So instead of having like a list of names, we could have a tuple with all the data for a single person. Again, something like maybe name and maybe age and maybe email address and maybe like a student number or something similar. So typically we just connect or collect all the data, all the properties of a single entity into one tuple. And then we can store these tuples in a list, for example. So we can easily create a list containing all the data of persons, for example. And this also solves the problem we saw before, that if we sort this list, then the data is still connected because all the data of a single person is stored into single tuple, and the tuple is also immutable, meaning that this data will stay together whatever we do with it. So let's see an example. Let's create a couple of more similar tuples. Paul Python and then Peter Python and I'm going to make some changes. And then we can again have a persons list containing all the tuples. And now if we want to output some data for all of them, we can again have something like this. And for example, output so now when we execute this one, we get all the names and emails of all the persons in that list. So tuples are great for connecting data that belongs together, like persons, properties, or coordinates, or whatever data. There are a lot of examples in the material how to use tuples. So, but using them is rather easy because they are basically like lists. And with tuples, we don't usually want to output the length. You can get the length of tuple if you want to, but we usually don't need to because we know the structure of tuples. That's because we usually use them in a way that we need to know the structure of them. So we are usually how we are using tuples. We are creating tuples and then we are accessing items from tuples, and that's similar to accessing items from a list. Okay, as I said before today and in the previous days, again, there are a lot of sort of concepts here, but a lot of these are easier to understand when you practice them yourself. So do you have any questions about whether it's matrices or references or dictionaries or tuples at this point? Yeah, about the last example, please ask away. Why the person 0 or person 2 gives all list? Aren't you accessing specific points? Yes, I am, but I'm doing it inside the loop in here. So now each of these persons is a tuple, and now this person zero accesses the item from first item in a tuple, which is basically the name in each of these tuples. And person 2 here accesses the third item in each tuple, which is this email address here. And this 4 person in persons now accesses all the tuples in a list one at a time. So yeah, it can, especially because we have persons and person, it can appear to be sort of difficult to understand. But yeah, it's an excellent question. Also, actually, one more example. So tuples are mutable. What if I want to change the age of a person, for example? The only way to do it is to create a new tuple based on the existing data. Something like this, for example. So let's say that we want the person to be 1 year older. That one for a second. So the only way to actually do it is just create a new tuple based on the data in the original tuple, and then we can just change the value. So now instead of 24, for Python is now 25, because it's not possible to assign items in a tuple because they are immutable objects. So this is like the downside of using tuples. But other than this, they are great for connecting similar data into a single item. Okay, thank you.